Welcome. In this session, we'll learn how do we create some important signals in Matlab. These signals are very important for system analysis. For example, the famous sine wave is very important in electrical engineering. Same way, in control system theory, we have impulse sequence, ramp signal, and this unit step signal. So how do we create uh, these, mm, these signals in Matlab and how do we plot these? Let's see that. First, what we are going to do, we are going to see this for continuous time signals. Then we'll do the same for discrete time signals and systems. So let's start with this famous sine wave. So to create this sine wave, I'm going to, first thing that we need is to define the time axis. So let's define this time from -1 to +1. Let's define this time. And what we are going to do, we are going to create an array that has values from -1 to 1 with difference of 0.01. As you can see in the workspace, T is defined as an array with 201 values. Next, what I'm going to do, I'm going to create another array that we name it as X. Then I'm going to, this will have the sign of this every T value, every value that is stored in this T array. As you can see, again, X is an array with 201 value. Next, what I'm going to use the Matlab's inbuilt function that's called plot command to display, see this sine wave. So if I press enter, this will give me the sine wave. This may not be visible to you because I'm just showing you the command window. Now I will switch to the figure window. Now you can see this is the sine wave. Now to make this plot fancier, I mean is to edit this plot to change the color and to see the grid and change the line width of this part. This is what we are going to do. I'm going to switch back to Matlab and edit this plot command. And what I'm going to do, I'm going to see the color of this plot is red and I'm going to set the line width of this plot. So let's suppose the line width is 3. And again, what I'm going to do, I'm going to label the time axis, X that says called as X label, and I'm going to put time there. So you can say time axis. Then to label y-axis, I'm going to say y label. So y label, I name it as amplitude axis. And I'm going to label this plot as, and so I'm going to label that is, we can put in this title command. Next, I'm going to turn on the grid. So I'll say now you can see the plot looks something like this. You can see the plot looks very fancier now. They have changed the color of this plot, you have changed the line width of this plot, and you have named this time axis and amplitude axis also. This plot you have named it as sine wave. So this is how we create sine wave in Matlab. Now we can further change the outlook of this plot by setting different markers on this. What I'm going to do, I'm going to set the markers, and let's suppose the markers I use are plus. So if I switch back to this, and you can see now the points are labeled as plus plus plus. This may not be clearly visible to you because I am using lots of points here. All right, so this is how we create sine wave, how we define sine wave Matlab. Next, what we are going to do, we are going to see how do we create an impulse function in Matlab or impulse signal in Matlab. Now to create an impulse sequence, I'm going to need an operator that's called a comparison operator in Matlab. Now what do we mean by comparison operator? For example, if I say is 1 equal to 1, so this is the comparison between what is on left hand side and what's on right hand side. This will do the comparison, meaning this checks whether 1 is equal to 1. And since this statement is true, Matlab will answer this will be equal to 1. Means Matlab will assign 1 to this statement. Means because this statement is true, 1 is equal to 1, so Matlab will give me the answer of 1. So you can see Matlab says that this is a logical one, means yes, this is true, false. So the answer here is true. Same way, if I say 1 is equal to 0, is this true or false? As soon as the statement is false, you can see Matlab answers that the statement is false by answering that the answer to this statement is 0. This is how we use this equality. Same way, you can have another comparison operator that says 1 is greater or equal to 0, and you can see 1 is greater or equal to 0, so this is true. So MATLAB will answer that, answer to this statement is 1. You can see MATLAB answers that this is, yes, this is 1. Logically this is 1. Same way I can say 1 is greater than 0, so this is another comparison operator, so this is 1. So why I'm showing you these comparison operators, because I have to create an impulse signal in MATLAB. I'm going to need this. All right, so to create an impulse sequence, what I'm going to do, I'm going to again first define the time axis. Let's define the time axis same way that we defined in the for the previous signal, that's the sine wave. So I'm going to define time varies from this -1 to +1. Next, what I'm going to do, I'm going to create an array that we named as impulse, and in this array what I'm going to store, I'm going to store the result of one comparison operation where t is equal to 0. Sorry, t is equal to 0. What this will do, this will store the values. This will compare each value of t with this 0. Means wherever t is equal to 0, this will set that value equal to 1. Rest of the values will be equal to 0. So this is an array. You can see impulse has again 201 values stored in it. So this creates an array with values that has 1 and zeros in it. So wherever this statement is true, that will have 1 value, and wherever this statement is false, that will have 0 value. So to give you a simple illustration of this, before I plot this, let me give you a simple illustration. Let's suppose our a varies from -5 to 4 or 3. Let's suppose a varies from, so a will have values from -5, -3, so you can see a is like this. Now what I'm going to do, I'm going to create another array where I put the values of the comparison, where I compare a with 0. And if I enter this, this will compare this every value of a with 0, and wherever it is equal, it is true, means when a value of a is equal to 0, it will put 1. Rest of the values will be 0. You can see this is 1 only at one place where the value of this sequence is a, and the value of sequence a is 0 here. So it will assign it to 1, and rest of the sample is. This is the statement I have used here to create this impulse sequence. So what's this doing? This will assign the values. This will check whether every value of t with 0, and if it is true, means if value of t is equal to 0, it will assign 1. So let me plot this sequence. Plot this signal. P comma impulse. Name of this array is impulse, and if I plot this, you can see the result. Let me switch to figure window. You can see this is an impulse sequence. Now you can again make this plot look fancier. I'm going to change the line width, and this, let's do that. Let's change the line width here. So what we are going to do, we are going to make it look like red. Let's suppose on the line width we take is, let's suppose 3. So then what I'm going to do, I'm going to also turn on the grid. So this you can see. Now I'll switch the window to show you the plot. So this is an impulse sequence. This is 0 everywhere except at one place where its value is 0, where its value is 1 here. Right? You can assign any value to it. We can say the impulse is equal to any value just by multiplying the sequence with that value. Means multiplying this x with any values. For example, to show you this, you can have any value of this impulse. Let me assign 5. So this is the sequence. Next, what I'm going to do, I'm going to execute this plot command again. Now you can see the value of this impulse is now 5. It's not 1, it's 5. You can see from this. So this is how we create an impulse signal in Matlab. This is the impulse signal in Matlab. Next, what we are going to do, we are going to see the continuous time unit step signal. Continuous time unit step signal. Again, what I'm going to do, I'm going to define the time axis from -1 to 1. To do this, so I'm going to create an array that varies from -1 to 1. This will store our time axis. And next, what I'm going to do, I'm going to do step is equal to, again, I'm going to use the comparison operator. So I will compare the values of t with this wherever it is greater or equal to 0, greater or equal to 0, means wherever the value of t is greater or equal to 0, it will assign 1. And if this statement is not true, it will assign 0 there. All right. So to give you an idea that what's going on in this, let me create again an array A. I already defined here. So you can see the values. Next, what I'm going to do, I'm going to define Y as an array. And to illustrate this, so this should compare the values of A with 0. So this statement compares the values of A with 0. Wherever A is greater or equal to 0, it assigns 1. Rest of the places it will assign 0. You can see this is from here onwards, the value, this statement becomes true here. So it assigns 1. So A is sort of a unit step array now. Now let me plot our step sequence that we created, and I'm going to make it look fancier. So I'm going to use the color red. Then I'm going to assign the line width equal to 3 here. And you can see the plot. Let me switch the plot. Let me name it also. So I will put title also there. Title is unit step signal. So this is our unit step signal. I should close the quotes. So now to show you the plot, you can have a look. This is indeed a unit step signal. This is 0 from -1 to 1, and from 1 to 1, its value is 1. Now you can change the time axis from any value to any value. You can do that also. I'm just showing you the plot from -1 to 1. You can change the plot time from any value to any value. So this is how we create a unit step signal in Matlab. Next, what we are going to do, we are going to create a ramp sequence. Now to create a ramp sequence, T is already defined, and what's the ramp sequence? To show you that what's the ramp sequence, let me switch to a different window. Let me switch the screen. If you remember what's the ramp, let me use this. So you can see the ramp sequence looks like, so the ramp sequence looks like this. It is 0 for negative values of time, and the value increases linearly as t becomes greater than 0. So this is our ramp sequence. Now how do we plot this? What I can do, I can use the step sequence. So to do this, I will use the previous step sequence. So what I'm going to do, I have t already defined. You can see t is already defined, means time axis is already defined from -1 to 1, already defined, and step signal is also defined. What I'm going to do to create a ramp, I will name the signal as ramp. Then I'm going to multiply this t with this step. And what will this will do? We know this step signal is non-zero only from 0 to this non-zero from 0 to 1, and rest of the values are 0. So when you multiply this t, and t is defined from -1 to 1, so it will make the values from -t to 0 equal to 0, and the rest of the values will be equal to will increase linearly as it gets multiplied by t here. Now why I'm putting this dot here, it means array multiplication. It means array means point-wise multiplication between this array and this array. Now show you this again to illustrate this. What I'm going to do, what's my a, what's my y? You can see this is a is an array that has values from -5 to 3. Y is an array that has values from that has values 0s and 1. So you can say if I plot this, if I plot this a comma y, it will give a unit step signal. Now what I'm going to do to create a ramp signal, I'm going to define one more this array, and I'm going to do the dot multiplication between y, this y and a. So to see that, you can see that this is indeed a ramp sequence. You can see the values of this r is 0 for -5, for -4, -3, -2, -1, 0, and as a becomes equal to 1, the value of this r is 1, and so on. This is how we create the ramp sequence. Same thing is going on here, same thing we did in this step, although the values are larger as compared to the values that are in these arrays. So to see the plot, let me plot this t comma ramp, and again I'm going to make it red color, and I'm going to change the line width here, and I'm going to do that 3. Then I'm going to turn the grid on. Then I'm going to name this plot title. I can put the title, this is ramp signal. Now let me switch the window. You can check this is indeed the ramp signal, and it increases from 0 towards 1 and goes up to 1. So as t increases, the value of the signal increases. This is the ramp signal in continuous time. So this is how we create these important signals in Matlab that are defined continuous time. Next, in the next session, what we are going to do, we are going to see the plot of same signals but in discrete time. We are going to see the plot of these signals in discrete time. Okay, let me stop here.